Okay, hello. I hope you can hear me, and I hope that in this stream we won't have any audio issues. Maybe let me check on YouTube if everything is going just fine or not. Mm, Okay, so it really takes some time to show in the YouTube. Hello, by the way. And so in a way, I'm having fun with the name, being a little creative, I guess, because right now I do really need a unique type of name, I should say, because so I was using BIN and bin, so that would just show me Mr. Bin, and maybe that wouldn't be very helpful for me or for the people who are trying to find videos. Maybe they are just not trying to find me, but still, um, everything should have gone just right, but still, I'm not able to see the live section in my mobile app. Okay, that is the very reason because I'm not going through the process of reading the documentation up here. Okay, let me check on the device. So I will turn off the display, but just know that I'm only looking if everything is fine. Um, yeah, and I will just mute myself, uh, or just mute the audio sound maybe, to see if the sound is coming just fine or not. Yeah, so everything is working just fine. Um, and I don't know, maybe let's start with it. Okay, so let's turn on our um capture and audio. That would be our desktop audio. And is there someone watching the video with me right now? I don't know. Um, so I'm trying to use my mobile device as secondary device to see if someone out there is watching or not. I'm not really sure. Yeah, so nobody is watching. Um, I don't know. So, anyways, let's start with our video. Okay, so let's go to the documentation. And we got caught off yesterday while I was making the explanation for pointers, and I think I did a good enough job at the previous video to explain that stuff. Um, so yeah, let's see. So now we are at string, literal, and Unicode point literal. Um, so we have const, bytes, and we have string here, and this other type of should be some kind of special notation of bytes that would give us pointer that is constant. Okay, so this is supposed to be length, and this is u 8 bit. We are just looking through it. We don't have to be completely right up here. Maybe get a feel of it. So while it is printing, we don't really have anything up here to print the type. And while we print the digit, so that would be 5, we need to put D in the curly braces. And yesterday we discussed about using C where there was character. Um, sorry, we were using S there while we had like string to print. So if we have character, we use C. Inside the curly braces, we use D for digit, and we can just leave the curly braces for boolean value, and again to the digit value, and yeah, this is true. That would be, we don't have to write anything. So yeah, okay. Um, hmm. Okay. So now I think we are seeing something that would be helpful as while we are learning, trying to learn about it, because everything up to this point has been like skimming through the content and not really doing the coding part, maybe, or understanding what we are supposed to take take away from it. So we have a const keyword to assign a value to an identifier. So we have x equals to 1, 2, 3, 4. We have a function. We return nothing, that is void. If works at file scope as well as inside the function. So this should be a global variable, I suppose. And we have y equals to some value. Once assigned, an identifier cannot be changed. So I think um, the const means that we are not supposed to change the value once it is assigned. So it's trying to change the value, but down here we are getting an error that we cannot assign to a constant here. So const applies to all the bytes that the identifier immediately addresses. Pointers have their own constness. Maybe we'll see later about this stuff. And if you need to need a variable that you can modify, then you can use the word var keyword like in JavaScript, maybe, if that makes any easier to understand or remember. So we have like const print, we have an import, we um, declare a variable y with type signed I signed 32-bit integer. We have the value here we're trying to change. We print it, and since it is a digit, we write d. And sorry, and we are skipping through the part of using dot and all of the stuff up here, but maybe we will get to look at this stuff once we get to stocks or something similar to that, maybe later in this continuation of part one, or maybe in the second part, or maybe I don't know, maybe in another video. Um, so we have a digit and we provide a value that is y and we print it. So variables must be initialized. It says um, so we are trying to use variable x equals to I32, and we haven't really assigned anything to it while we initialized it. So it says var must be initialized equals to nothing found. So yeah, use undefined to leave variables uninitialized. So if we are trying to initialize variable, but we don't really know as what the value is supposed to be at the initial stage, we can just write undefined, and that would be like we don't know. And by the meaning of the word itself, it is not defined. So we can just assign the variable to it later in the code section, and then we print it like before, putting in digit here and assigning the corresponding values. Okay, we are not looking at check test. We should start from variables, I think, and maybe from here we will have a better progression, and maybe the syntax um uh, that would help us align our you know motive to learn what all the stuff mean in the jig code, because unless we know the syntax that is used in a language, we don't really know what is happening. We certainly have a general understanding as we have used another language, but sometimes even a dot can do things that would just alter the program, maybe even do something opposite of what we might assume the program would do. So it is very good idea to understand what the language syntax means really well. Okay, so we start with variables. And I think if you have watched the part one, and if you're watching this one, and you think you are in a hurry, maybe, um, and still want to watch maybe stream or video to learn about it, learn about the language, then you can just skip to this part and start from here. Okay, so variables. A variable is a unit of memory storage. So everybody knows variables is used to store values, more like an identifier. So it is generally preferable to use const rather than var when declaring a variable. This causes less work for both human and computers to do when reading the code and creates more optimization opportunities. The extern keyword or at the rate extern built-in function can be used to link against a variable that is exported from another object. Okay, maybe we will see something later. But first, we shouldn't go that fast toward using some CABI compatible objects. Maybe we should take a step back here. Okay, so let's see here. So we have container level variables. Container level variables have static lifetime and are order independent and lazily analyze. The initialization value of the container level variable is implicitly compile time. If a container level variable is const, then its value is com time known. Otherwise, it is runtime known. So it is saying that if we have like a container variable, then static lifetime means it will stay as long as the program runs. So we have var y equals to something something. So we are add x. We don't really have to know all of the things, but we are just trying to understand the container level variables and its lifetime maybe. So by lifetime I mean the time until which the variable can be used or is accessible. So we have x I32 and we then add both this variable. So this is a test. Okay, let's not try to look into it. So then we have add this and this. We return some variable. Okay, yeah. I don't know what it still doesn't feel that right. The documentation hierarchy. Anyways, huh. So it says container level variable must be declared inside a struct union enum opaque. So I think most of you should know what a struct is, what a enum is. Maybe union and opaque may be something new. And by the way, I too don't know what these two means. So I also have to look through it and understand for myself. So we have standard library here, and we have expect standard library dot testing dot expect. So this is for testing. We can just ignore it for now. Const s equals to struct. So if you are trying to create a struct, and I think it would be like anonymous struct type because we are not really giving any name. We are directly assigning a struct type here to a variable s. So we have variable x I32 and we have given a value here. So fn foo I32 return type, we have s dot x plus 1 return s dot x. So everything goes just fine. Okay, so yeah, so it is just using the dot symbol as you guys might have used in the dictionary of Python, maybe in objects of JavaScript like JSON or something like that. So we'll go through static local variables. It is also possible to have local variables with static lifetime by using container inside functions. Okay, so we have a static local variable. We're trying to expect who equals to this, and this is trying to just check. So suppose try means um, whether it is true. If true, then maybe just ignore it, and if false, then maybe halt the program. It should be something like that, but we are not really trying to get deep into the testing process. So, anyways, then we have the main function, more or less the similar thing here. So I think it's just talking about the scope of the variables that are being used. And I think we don't really need to go that deep because I think this is just a trivial thing with that you can just look at it and we can understand it. And even by um, just virtue of having a programming experience in other language, you can just use it, and I think you will be just fine there. Okay, then. So we have thread local variables. It might be a bit different than what you might have seen in the past. So we have a variable maybe specified to a thread local variable using thread local keyword, which makes each thread work with a separate instance of the variable. So um, so I think the try is more or less the um do we say the error handling part of things probably, and I think we should get to that. I don't know when, but we should have some kind of section up here, yeah, in errors, and we have try, and we have a lot of things to cover. So yeah, so we have test thread local storage. We are not really looking at the thread, but still we have a thread local variable defined at the very top of the program. So it would have like a static lifetime. That means the variable will exist for at the until the end of the program. And since we use thread local, so it would be like um, combination of thread safety, but a bit different maybe. So let me explain it. So since its initial value is 1 2 3 4, as you're trying to use it in different threads will take the initial instance of it and create their own instance in the thread to use it. So it's like creating a variable and which will be accessed by different threads, making different instances of it. Like let's assume that if you are using Java, so let's assume that this is a class, and so you create objects more or less. That would be like that, but in context of different threads, it will have different instances. So the two will not interact with each other. So we are not using any kind of log or mutex or anything like that. We're just providing different instances of sorry, variables inside different threads that do not communicate with each other. Okay. So for single-threaded builds, all thread local variables are treated as regular container level variables. So it is talking about the scope of the variables. Um, Thread local variable may not be constant. So we have local variables. Local variables occurs inside a function, com time blocks, and cl c import blocks. So I assume this will be like using some kind of code or linking some kind of C object file with a header file. I don't know, that should be something like that. Anyways, it's talking about local variables is more or less related to the scope of it. Let's see here. Local variable may be qualified with com time keyword. This causes variable value to be com time known that will and all loads and stores of the variable to happen during semantic analysis of the program rather than its runtime. All variables declared in a com time expression are implicitly com time variables. So what do we have here? So we are testing here. We have variable x I32.1 com time y equals to I32.1. We are changing something up here. We are changing the value of y, trying to um, um, just test the values. If y is not equals to 2, then we have something here, com time error at the rate wrong y value. So um, we have a lot of, not that much of code I should say, but anyways, we have a special type of here comp time. So the text up here is saying that if we use comp time um, ahead of the initialization in the program, and the full form of comp time would be compile time, you know. So if you know something, the value of something at compile time, that means you don't really have to run the program to know the variable. That means you can just look at the program and you know for the fact that what will be the value of the variable will be when you run the program. And that is very useful for the memory and for the compiler itself, to know what to do with the program. Um, you can also assume that to be a static value at the runtime after it has run through all of the possible expressions. Maybe I'm just making it a little sound a little bit too complex, but understand this. If we have a comp time variable, that means we know the value of the variable at the compile time. That's it. Okay. So yeah, and this comment might help. So let's read this. This compile error never triggers because y is a comp time variable, and so y is not equals to 0 is a comp time value, and this if is statically evaluated. So yeah, so that means we don't even really need to run this at the compile time or at the runtime, I should say, because the compiler would know that the value would be just fine and we don't have to worry about any of this stuff not being true. So now we get to the integers. So we are getting to the very integral part of the um, jig language up here at the very initial part, I should say, but still we are getting somewhere with the documentation. um, so we have integer literals, we have const, that means that won't change, we have variable name, decimal int, and we have some kind of variable, I suppose it is just dynamically getting the type of the variable, like what you might use in Go. If you don't really know what I'm talking about, maybe I could talk about it in some kind of note. So let's get a pen maybe a little bit thicker. Okay, so in Golang, if you have used like this kind of a syntax, I'm just pointing it out with the box. So you can't really write the box. I think you know that. So this these two elements, mostly this. So this will just know the value of the variable one, and we don't really have to write like a that is I8 maybe equals to 1. We don't have to write the I8 part. Um, that would be just known at the compile time. So yeah, so we have hex int, we have hex value here, another hex value, octal integer, we have binary value. Underscore may be placed between two digits as a visual separator. So we could also do something like as you do in a number system while you are writing a large number like 1 comma 0 0 comma 0 0 0 or something like that. We can just write underscore and it would know that we are just writing it to separate it and just for the visual aid so that we would understand what the value would be just by looking at it or would make easy for us to learn the value. I think that is very clear. We have a binary mask, all the same. We have big address. Anyways, we have runtime integer value. Integer literals have no size limitation, and if any undefined behavior occurs, the compiler catches it. However, once an integer value is no longer known at compile time, it must know a known size and is vulnerable to undefined behavior. Okay. So I think it is referring to the above example because we are not really trying to give the value of here like I8, I16 or even U16, something like that. The compiler knows what the value would be and it doesn't really have like limit, but it certainly does have a limit. But you know, it knows. But if we haven't given the value, then it would be vulnerable to undefined behavior. So in this function, value a and b are known only at runtime, and thus the division operation is vulnerable to both integer overflow and division by zero. Such operators such as plus minus cause undefined behavior on integer overflow. Alternative operators are provided for wrapping of saturating arithmetic on all targets. Plus, and this is should be the remainder and minus remainder perform wrapping arithmetic while okay perform saturating arithmetic. See about that, but maybe we need to see through it. Okay. So it is saying it uses to complement representation. We have already discussed about that in the previous video. I mean, normally all the compiler do use that, so it's not really a surprise. So F16 follows the IEEE 754 representation. So binary 16. Yeah, all of that. We don't really need to go deep into that. So we have floating values and all of that. We can just use equals to and just assign the value. So that isn't really new. So we go through float special values dot check. So we have int dot inf f32. What does that mean? So there is no syntax for nan, not a number, infinity or negative infinity. For this special value, one must use the standard library. Okay, so my.inf means infinity, and that would uh, be in format of f32. And we are doing negative infinity, standard math dot infinity. We have a minus up here, so negative infinity, the variable name, and the size will be f64, and we have, what is this, man, not a number, the value would be f128. Okay, so if you are trying to use infinity, negative infinity, um normally, then you just have to use the standard library um to accommodate with the compiler. You can just do that, and it is really easy to understand. To I mean, I didn't really even knew what this meant, and I just read the text up here, and I got the idea what the inf means, because it's infinity, and that is a very simple thing to look through. So we go to floating point operations. By default, floating point operation uses strict mode, but you can switch to optimized mode on a per block basis. So what does that mean? So we have standard library, we have a big, so I assume it's a big integer, and as, so f64, it is trying to do, I think it's, what do we say this? Bit shifting. So we have the value 1, and we are trying to shift it through 40 position. I think we're trying to convert it to f64 type. Am I right? I don't know, we'll see. um we have export fn foo strict x f64. We return f64. So we have x value, we add the big and subtract the big. Export fn optimized x f64, and we return the f64, and we have set float mode dot optimized. We return x dot big minus big. I I don't really know what is the difference between these two. I mean, I certainly get it that it would be more optimized and it would be processed per block, but still. And I was right, as this was trying to change the type of this value to f64 with using at the rate as, because we are trying to input up here, and we can't really do plus or minus with values that are of different types. And now, okay. So something different about that. Set float mode dot optimized. I don't know if it uses like less bit than it has to, because it don't doesn't really need the total 64 bit up here, because even if we shift 1 to 40 bits, then it would need like um I don't know, um so it should be let's assume this. So where should we go from here? uh 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 this isn't really that big. um this is 5,000, 5,000. And so let's assume this. So if you are shifting 1 to 40, and we are supposed to have like 64 bit. So, and generally, while counting the bit value, so let's assume we only have like 8 bit, 8 bit of value, 8 bit of value. So like 1, 2, 3, 4, 5, 6, 7, 8. So if we have like, I don't know, 0, 0, 1, um, and all the zeros up here. So we don't really need this part up here. We can just take this part and be done with it. Don't really need to use this extra bits. I think that is what is going on up here with optimized. Um, but I'm not sure about that. Okay, so we have like operator syntax up here. Addition, we all know that, all know this. A plus b, we have assigning it to a by adding the b. Okay, we know that. We are wrapping addition. What does that mean? Choose complement wrapping behavior. As you thought it to some bit up here, we are adding plus, and okay, this is new for me. Is this two, I should say. We have subtraction. Everybody knows that. Wrapping subtraction, saturation subtraction. Maybe in another part we should see about this. Maybe I'll try to get more information about this and get back to you. We have negation. We can use just minus in front of it. Um, we have wrapping notation. So this is a new one by using this sort of things. Okay, wrapping and saturating. We need to understand that, and I will get back to you guys as soon as I can. So, the remainder one, we all know that we have bit shift. So I think I have given the example of that. So this will be bit shifting left, and this is a bit, where is this? Bit shifting right. So anyway, if something like I think we are using this. So let's Let's assume we have what is going on in here. Uh, we have like four bit of values. Uh, let's say that we have like this 1 0 0 0, and if we do something like uh, we are going to left shift it by 1, then this means 0 0 1 0. So this value just gets shifted one bit up here. So this is shifting left, but if we just shift it one bit by right, fuck me, I don't know what is wrong with this. Yeah, better now. So if we do something like 1 and then we do right shift, then it will come back to the original form. So it will go back to 0 0 0 1. So this is right shift, this is left shift. Uh, so properly I would call this is left bit shift, and this is right bit shift. Um, so we have bitwise or, bitwise and, bitwise XOR. Okay, so XOR means only one can be one, both can't be um, um, one. So if we look at the example OV011, OB101, so at the initial value we have 1 and 1, so it will be 0. It is 0 and 1, so it will be 1. We have again 1 and 0, so it will be 1. Only one can be one of the elements in both corresponding values can be 1, not both. So that is exclusive OR, and by the word itself, it means exclusively only one can be OR. So yeah, that is the operation of bitwise XOR, and we have bitwise NOT, uh, logical AND. So if we do false and true, it will be false. Logical OR. So if any one of these left or right side would be true, then we will have true. Boolean NOT, we can just use the bang sign, and we have equality for comparing. Null check. So if we have something like this question mark, so it could be null or not. We have um, inequality. We have non-null check, greater than, greater than or equal to, less than or equal to, array concatenation. So we may have two different arrays. If we do something like this, then I suppose we'll have both of these arrays combined together. We have array multiplication by using double asterisk. We have pointer dereferencing, a dot, and then we have dereferencing. So it's pointer dot dereferencing. Okay, so this is the part I was talking about the referencing. So x is this value, and we copy the reference of the x up to the pointer variable, and then we do the dot dereferencing this symbol, and we will have the value inside of it. if we didn't do it, then it would give us the initial um, memory address that the value is stored in, but not the value. So address of, if we need address of the thing. So as I was talking about, it isn't really shown up here, but I think you guess what, you got what I said earlier. We have error set merge. So we have a and double like or, but error set type merging error sets. We have error 1, we have error 2, and if we do like error set type, then it could be error 1 comma 2. I think we have to look into that, but still. And this is the precedence of how things will be analyzed in the program. So you can just look through it. And in a way, I do have a work to complete. So sorry for just ending the stream so early. I was thinking about doing like 2 to 3 hours of stream, but I think for today I have to just end it up here. So if you have any queries about it, if you want to know something about maybe another language, then just hit me in the comment. And yeah, thank you for watching, and we'll meet again. Bye.